Good afternoon and welcome to Chegg's live Stoichiometry Office Hours. It is so great to have you. If this is your first time, we are so happy to have you. And if you're coming back, you know the drill. Thank you for showing back up. My name is Allison. I'm going to be your hostess for tonight. I'm teaching the Stoichiometry Office Hours. I have TA'd for regular chemistry, and then I've been a tutor or an SLA is what we call it at my university for organic chemistry, regular chemistry, and nursing chemistry, and then a tutor also for calculus. I love teaching, love chemistry, love math, so it's fitting that I teach the stoichiometry office hours. I'm a chemical engineering student at the University of Louisville, so any questions regarding chemistry, math, I've got you. And the way it's going to go tonight is I encourage you to ask your own questions. So anything you've went over in class, any homework problems, anything that you have, type that in the chat of wherever you're streaming from. And I would be happy to answer that question for you right now. I'll go step by step so that you can see how the problem is solved and learn from it. While we're waiting for questions, I'm going to go through some questions I wrote. Tonight, I made them more challenging since we're getting to the end of the semester and closer to that finals. So this is a great practice for a final that you might be taking. And I'm going to encourage you throughout this process of going through the questions that you answer, you follow along, you participate. So I might ask you how you would solve the problem or a step or to do some math. I really encourage you to do that so that you can learn and we can all benefit from this live stream. So it is great to have you, and let's get started. Our first question is a limiting reactant question. It is if 10 grams of aluminum reacts with 75 grams of hydrochloric acid, what is the limiting reactant? This is actually a 3-part problem. A lot of teachers will do a 3-part problem with limiting reactants, so it's great practice. Here's our chemical equation. Y'all are super lucky because I already balanced it for you, so you don't have to worry about that. But let's do the limiting reactant. So now is your cue to start participating. What are the steps that you would take to solve this problem? You have about 30 seconds. Tell me any steps that you would take to solve this problem. You can also tell me what a limiting reactant is, why we want to know what a limiting reactant is. So any information on this problem, you have 30 seconds. Let me know. About 10 more seconds. Anything you know, type that in the chat of wherever you're streaming from. 3, 2, 1. All right. So we are going to start with these grams that the problem gives us. So that 10 gram and that 75 gram. These are our reactants. Now, just for a little background, if you haven't seen this type of problem before, or if it's been a while and you learned it at the beginning of the semester, so you're needing a refresh for the final, our limiting reactant is the reactant that causes us to make less product. So the limiting reactant causes us to make less product. There's also an excess reactant, which that reactant is an excess to create product. So limiting reactant prevents us from creating more product, kind of in the name, so it's pretty easy to understand and remember. But we're going to start with 10.0 grams of aluminum, 75 grams of HCl. All right. Now, does anyone have any ideas on what we are going to be calculating? What do we need to calculate to find the limiting reactant? And I kind of gave a hint with telling you what the definition is. So remember, it's limiting the product we can make. So if you said we're going to go to grams or moles of a product, you are absolutely correct. I always choose the first one. So I'm going to make our grams of aluminum and grams of HCl converted to aluminum chloride. So I would do grams of Al on the bottom and then moles of Al on the top, because if I want to convert in between different compounds or chemical formulas, I have to go to moles first. Moles is that middle ground conversion for everything. So same on the bottom, I'm going to go grams of HCl to moles of HCl. And that is our first step. And then lastly, just like we talked about earlier, just like some of you guys said, we want to go from moles of HCl to moles of our product. So moles of AlCl3, if I can Right, it's been a long day. Hopefully, final studying is going well for everyone. Or if you're not quite to finals yet, hopefully you're having a nice, relaxing break before. All right. So let's do this. All right. We've got it set up. Now we just need to fill in this conversion factor label method with actual numbers. So we need grams of aluminum to moles of aluminum and grams of HCl to moles of HCl. You guys have, let's do 1 minute to get both of these. At 30 seconds, I will start writing. This is finding that molar mass if you're a little bit confused. So we want to find the molar mass of both of these. All right, so Al, if you just look at the periodic table, that number with the decimal points is your molar mass of aluminum. So 26.98 grams of aluminum per mole of aluminum. And then for HCl, we'll have to calculate that. So we have 1 mole of H and 1 mole of Cl in HCl. H is 1.01, and then Cl is 35.45. So we're just going to add those together, and we'll get 36.46 is our grams per mole of HCl. So I'm going to put 36.46 to 1 mole. And now I just need those mole to mole conversions. Does anyone have any idea on how we find those? I think this is probably the part that most of my students struggle with when solving these problems. So it's really important that you know where you get all the numbers from. So when that test, when that homework comes, you are ready to roll with it. About 15 more seconds. Where am I getting these mole to mole ratios from? All right. If you said this chemical equation balanced, that is absolutely correct. So we just find the coefficients of those compounds and we plug the numbers in. So AlCl3, you can see right here it has a 2. Al, you can see right here has a 2. And then AlCl3, again a 2, and then HCl has a 6. So now we are ready to put that in our calculator. I'm going to give y'all 1 minute, put both of those in your calculator, and let me know what you get. So we want to solve for how many moles of aluminum chloride each one creates. I'm going to write some of the answers on the board, but don't look if you're still solving. I definitely encourage you to solve first and then look and check, because you'll never learn and you'll never grow if you don't try these problems on your own. I think that was the hardest thing for me to grasp about chemistry is I could watch people solve the problems all the time, but if I didn't do the practice and I didn't do the work and try to solve them, I never actually knew what was going on. All right, about 15 more seconds. Finish those answers. Type in the chat which you think the limiting reactant is. That way you're checking your work. 3, 2, 1. All right, so these are the moles you should have got for each. So you should have got that 10 grams of aluminum produced 0.3706 moles of aluminum chloride, and then 75 grams of HCl could produce 0.6856 moles of aluminum chloride. Whichever number is smaller is your limiting reactant, because again, that limiting reactant creates less product. So aluminum is our limiting reactant. If that makes sense, you can type yes and we're in the chat of wherever you're streaming from. If you still have questions, let me know. Type those out. I'd be more than happy to answer them for you. And if you're just now joining, it's so great to have you. My name's Allison. I am your host for tonight. I encourage you to ask any questions you have throughout the live stream. My goal is to help you and to cater this learning to you. So any questions you have, type those in the chat of wherever you're streaming from, and I will answer them on the spot. All right, next we're going to go to how many grams of hydrogen gas are produced. So this is like the second part to our problem. We want to know how many grams of hydrogen gas are produced. How do we do this? I'm going to give y'all 30 seconds, create a game plan for how we would solve this problem. Type it in the chat and we will check our answers, see who's right. So create a game plan to solve for how many grams of H2 gas are produced. About 10 more seconds. All right, 3, 2, 1. So to pick out how many grams of hydrogen gas are produced, we need to go from our limiting reactant to our grams of hydrogen gas. You have to choose the limiting reactant because your limiting reactant is preventing how much product can be made. If you use the grams or moles from the hydrochloric acid, which is the excess reactant in this case, then you will be getting an incorrect estimate of how much gas is produced because the excess reactant is like the ideal situation and it's not an ideal situation. So we need to use worst case scenario, use that limiting reactant. So I'm just going to, because I think it's easier and it's already in moles, we can use this number right here, which is our 0.3706 moles of AlCl3. A little trick that takes like a lot of practice to kind of comprehend. Any number you can convert that limiting reactant to, you can use. So if my options are to convert from grams of aluminum to grams of H2 gas or moles of AlCl3 to H2 gas, I think the moles is so much easier because it eliminates a step of that process. So it is a little difficult to comprehend. If that doesn't make sense to you, we can do the grams of aluminum. But for right now, unless we have anyone saying they want to see it the other way, we are going to use our 0.3706 moles of aluminum chloride to convert to that grams of H2 gas. So 0.3706 moles of AlCl3. And then we want to go to grams of H2 gas. So this is where you're going to actively participate. Any steps that you know to solve this problem, type that in the chat, and I'd be more than happy to answer. So first, we're going to go from moles of AlCl3 to moles of H2. So that's that first step, mole-to-mole conversion to get to the product we want to create. And then we go from moles of H2 to grams of H2 just because the problem asks for grams. So now let's put those conversions in. I think I told y'all that y'all should tell me the steps, but then I didn't give y'all enough time. But now I am going to give you enough time to figure out the numbers associated with these steps. The numbers are the most important part. You can't calculate anything if you don't have the numbers. So figure out the numbers to these steps. You've got 30 seconds. All right, 15 seconds. What are the numbers? How would I convert from moles of aluminum chloride to moles of hydrogen gas or moles of hydrogen gas to grams of hydrogen gas? All right, 5, 4, 3, 2, 1. All right, moles of aluminum chloride to moles of H2, same as we did in the problem above. We're using those coefficients from the balanced chemical equation. So AlCl3 has a 2 in front of it and H2 has a 3 in front of it. So that's where I got those numbers from. Let me write this 3 so it's easier to read. Okay. Now, moles of H2 to grams of H2, that's that molar mass. We can quickly convert it. It's just 2 moles of H times 1.01 grams per mole. So we'll get 2.02 grams per mole of H2. Hopefully that's making sense. Again, if anything is tricking you, you're not quite sure about, let me know in the chat. I'd be very happy to answer that for you. So now let's plug that into the calculator. I'm going to give y'all 30 seconds. Put this in the calculator. Try to beat me to solving the problem. I'm going to be putting it in a calculator too, so we'll see if you can beat me. All right, you have got about 10 more seconds. All right, 5, 4, 3, 2, 1. Your answer should be 1.12 grams of H2. Hopefully that's making sense. Again, if it's not making sense, let me know. Be more than happy to help. And if you're just now joining again, ask those questions. It's so great to have you on the live stream. And anything you need help with, anything you are looking at to prepare for finals that you're not quite sure on, let me know. I'd be more than happy to help. And then our last part of this 3-part problem is how much excess reactant is left over. So how are we going to figure out how much excess reactant is left over? Does anyone have any ideas? This is a really good problem. I know it's long, but it's such a great problem for problem solving, thinking through chemistry questions, and it helps you get in that mindset for any curveballs your teacher might try to throw at you on an exam or a final. So I think it's a great problem to think about chemistry things from a different perspective. And it's great limiting and excess reactant practice, which I don't know a chemistry teacher who doesn't love these types of questions. All right, so how much excess reactant is left over? If you said that we need to now convert this 1.12 grams of H2 to grams of HCl, you're correct. So the reason we're going to convert this to grams of HCl, so we're at this limiting reactant. We're using that to convert to all these different types of compounds in the chemical equation. Now, if we convert back to grams of HCl, we can subtract 75 minus that conversion of the limiting reactant to figure out how much excess will not be used. Might be a little confusing, so ask any questions you have, but I think as we do the math, it should make a little more sense. So I'm actually going to use this 0.3706 again, because again, it's that limiting reactant conversion. It's the easiest. It takes the least steps as opposed to starting with grams. So 0.3706 moles of AlCl3, and we want to convert to that grams of HCl, just so we see how many grams were used, and then to figure out how much is left over, we'll do what we started with minus what we used. So 0.3706 moles of AlCl3. Whoa, that's a tongue twister. And then we're going to do that to moles of HCl. And then moles of HCl to grams of HCl. All right, this is your guys' time to shine. What are those numbers to fill in? You've got 30 seconds. Whoever gets the most right gets a virtual high five. So you've got 30 seconds. Put those numbers in the chat so that we can check our answers. 15 seconds. See if you can beat some other people typing their answers in the chat and get more correct answers. So we want to figure out all those numbers. All right, 3, 2, 1. Okay, if you said there were, for moles of HCl, we'll have to go back up to that balanced equation. There'll be 6. For AlCl, again, 2. I just got those numbers from the coefficients. And then for this right here, we didn't. Wait. Yeah, we already converted, got the molar mass of HCl up here. So we can just use that conversion. So we do 36.46 grams per 1 mole of HCl. And then let's just put that in our calculator. 0.3706 times 6 divided by 2 times 36.46. And we got 40.53 grams of HCl. But we're not done yet because we need to find how much excess reactant is left. So let's do what we started with, which is the 75 up here. So 75 grams of HCl minus 40.53 grams of HCl. So if we put that in the calculator, we get 34.47 grams of HCl left over. Hopefully this is making sense to everyone. Again, if you have any questions, let me know. I'd be more than happy, to solve them for you. If you're just now joining, all the questions you can, ask them. I'm here to help you. I'm here to make stoichiometry less daunting, or chemistry, math in general. Any of those things you have questions about, I would love to answer them for you. And it is so great to have you join this live stream. Thank you to Chegg for putting this together. And let's move on to that next problem. So we have ethylene reacts with oxygen to produce carbon dioxide and water. It gives us this nice chemical equation, already balanced. You're welcome, guys. If 45 grams of ethylene reacts with excess oxygen and produces 78 grams of carbon dioxide, what is the percent yield? All right, I actually don't think we've done a percent yield on the Stoichiometry Office Hours yet. So this is going to be new for everyone. But since you might have done it in class before, I want to give y'all the opportunity to test your knowledge. You have 1 minute. Tell me anything about how you would solve this problem. 1 minute starts now. Any details? If you can solve the entire problem in 1 minute, I will be extremely impressed. All right, about 30 more seconds, guys. How would we solve this percent yield problem? Any ideas? Does anyone have any ideas? 15 more seconds. You guys got this. Show me your knowledge. Let me know in the chat how you're doing. 3, 2, 1. All right, now let's solve. So we want to find percent yield. This problem actually gives us a really nice tip about what we're going to need to convert. Always read the problem and try to find the clues the problem gives you. So the clue here for me is excess O2. When you see that word excess before a compound, you know that's the excess reactant, which tells us that C2H4 is the limiting reactant. So C2H4 is going to be the important thing for that percent yield. So we're going to start at 45.0 grams of C2H4. To find percent yield, we can do grams or moles. I'm going to choose grams because it doesn't specify. It might specify mole yield or gram yield, but since our grams of carbon dioxide is already in grams, I'm going to convert the grams of C2H4, which is ethylene, to the grams of carbon dioxide. So I'm going to go grams of C2H4 to moles of C2H4, moles of C2H4 to moles of CO2, and then that moles of CO2 to that grams of CO2. Hopefully that's making sense. You can send a thumbs up or a yes wherever you're streaming from, just so I know. If you need me to go slower, let me know that too. I would be more than happy to do that. All right. So now is your time to shine yet again. You're going to have 1 minute to figure out these conversions. You're also going to need to find out that molar mass of ethylene and carbon dioxide. So 1 minute starts now. I'm going to start writing in a few seconds, but don't look if you're solving the problem. And I encourage you to solve the problem so you learn and you get some practice in. All right, again, don't look if you're solving, but if you're struggling and you need help, look, and I will have some tips up on the board to help you. All right, that first molar mass is up there for C2H4. So if you're stuck on finding that molar mass, you can look up on the board now. I'm going to go ahead and fill that out in our actual problem. All right, now we're going to do CO2. So again, keep solving if you're working. Y'all have got about 15 more seconds of work. All right, and you should have got 44.01 grams per mole for that carbon dioxide. All right, and then for CO2, for that moles of CO2 and moles of C2H4, just like that problem above, we're going to use those coefficients in the balanced chemical equation. So I see a 2 in front of CO2 and a 1 in front of C2H4. Let's put that in the calculator. All right, you should have gotten 141.16. I'm going to double check that because that seems, I guess that's right. So 141.16 grams of CO2. Now let's find that percent yield. So I'm zooming out so y'all can see the entire problem. 1 minute, figure out the percent yield. If you haven't known anything till this point, I think we can find the percent yield. So everyone, I'm giving a chance to try and get the answer to this problem. Let's see who can get the answer first and type it in the chat first. All right, 30 seconds. Who can type the percent yield in the chat first? No guess is a bad guess. If you are scared your answer's not right, still type it so that we can work through how you may have got that, and I can show you where to correct that to do better and get the answer right in the future. About 20 more seconds. You've got this, guys. 5, 4, 3, 2, 1. All right, to find that percent yield, we're going to do what the problem gives us. So this is what was actually produced. So real quick, we'll do a little lesson on percent yield since I haven't been over it before. Percent yield equals actual over theoretical times 100%. So that's the formula for percent yield. So actual was our 78 grams in the problem. Our theoretical was this 141.16 grams. Then we do that times 100%. So we're going to put that in our calculators. And we multiply by 100, we'll get 55.26%. That's not making sense, or if you want to do another problem like this, let me know in the chat and I'd be more than happy to go over it for you. But that is the answer. Any questions, let me know. If you're just now joining, it's so great to have you. I'm Allison, I'm your instructor for tonight, and we are doing some stoichiometry problems. If you're looking for more office hours this week, you can go to that QR code in the top left. It'll have all the office hours Chegg offers, anything from algebra to calculus to organic chemistry. So if you're looking for more help, more practice before finals, I encourage you to check out that QR code. And let's move on to the next problem. Oh, also, ask your questions. I'm here to help you. I want to help you learn in any way you need. So any questions you have, type that in the chat of wherever you're streaming from, whether that be YouTube, Twitch, just let me know, and I'd be more than happy to help. Our next problem is how many milliliters of 0.250 molar hydrosulfuric acid, whoa, it's a tongue twister again, are required to completely neutralize 50 milliliters of 0.4 molar sodium hydroxide. We have, again, a beautifully balanced equation. I didn't make y'all do any balancing chemical equations tonight, so you should be very, very thankful. Just messing with you guys. But let's figure out how many milliliters are required to completely neutralize that NaOH. So this is a little bit of a confusing problem. When I wrote it, I was a little confused, but I think I'm going to give y'all 30 seconds just to think about it. I just want you to think of the problem. Think of how would I solve this problem? And honestly, I think it might be more confused. It might be less confusing than you think. All right. Giving y'all enough time to think. I want to work through this problem together. There'll be steps along the way where I will give y'all some time to participate, but I think the majority of this problem, since it is a little confusing, it's important we work together and we learn together. The way we're going to want to start with this is we're going to take these two numbers right here. We're going to multiply them to get a moles of NaOH. Like I said at the beginning of this live stream, moles is your conversion from anything. So if you ever need to convert in between chemical formulas, that's your cue to use moles. You can't convert from NaOH to H2SO4 without moles. You can't convert from calcium to hydrogen without moles. Anything to convert from one element or molecule to another, you gotta have those moles. So the way we can do that is we have 0.400 m, which is also 0.400 moles per liter. And then we can convert that 50 milliliters to liters. And then we multiplied by that liters to get just moles of our NaOH. Hopefully we're following along. I know that's a little tricky, but this first step that we're doing is just to find moles of sodium hydroxide. And you should have got 0.0200 moles of NaOH. Is this making sense so far? Send a thumbs up, send yes in the chat if it is. If it's not, let me know any questions you have, and I would be happy to go over them in more detail. So again, first step, just finding that moles of sodium hydroxide. We did that by doing molarity times the milliliters. Now, one thing that when I originally saw this problem that I thought, oh, let me do that, I was thinking to do dilution, which is M1V1 equals M2V2. If you haven't heard of it, just ignore what I'm about to say. But if you have, the reason we can't do M1V1 equals M2V2 in this problem is because we are not converting within the same compound. If it was the same compound, if it was like how many to convert to 0.3 molar of NaOH again, then we could use that formula. But since we're going from NaOH to H2SO4, we have to convert to moles. So we are at our moles now. And now we want to convert to H2SO4. Hydrosulfuric acid and sodium hydroxide are both a strong acid, so they should cancel out by conversion. They should neutralize that way. So 0.0200 moles of NaOH to moles of H2SO4. Hopefully we're still following. Again, if you're not, there's no shame. Let me know, and I would love to go over this in more detail. I would say this is probably one of the most confusing problems that we've done. It's not necessarily difficult math-wise, but to conceptually wrap your head around it, it is pretty hard. But I wanted tonight to be a challenge so that we could all start preparing for finals and those last tests of the semester. Now, this is your time to shine and participate. What's the conversion from moles of sodium hydroxide to moles of hydrosulfuric acid? 30 seconds, go now. 3, 2, 1. Again, like we said earlier, if you got this right, virtual high five to everyone who got it right. We're just taking those numbers from the coefficients. So that 2 right there and that 1 right there. So 1 to 2. Now let's put it in our calculator. Hi, Jessica from YouTube. It's so great to have you on the live stream. Any questions you have, let me know, and I'd be more than happy to answer them for you. This is Chegg Stoichiometry Office Hours. We're doing stoichiometry, chemistry, math, all of it. So any questions regarding those things, let me know. I'd be more than happy to answer them for you. All right, if we put that in the calculator, we have 0.01 moles of H2SO4. And now we're almost done. We want to figure out how many milliliters of 0.250 molar H2SO4 are required. So how are we going to do that now? We are going to start with our 0.01 moles of H2SO4 and use that 0.250 moles per liter of H2SO4 as a conversion. That's what we're going to do so we get milliliters in the end. So we would put 0.250 moles on the bottom and 1 liter of H2SO4 on the top. And then last, the problem asks for milliliters. So we need to go from liters of H2SO4 to ml of H2SO4. And that's an easy conversion we all know. So if you need that conversion, let me know in the comments. Or if you know that conversion, let me know. I should say I'll give that conversion to you in just a few seconds. But if you know the conversion from milliliters to liters, let me know. If you have some exam questions you want to go over, just let me know in the chat. Type those out, and I'd be more than happy to help you. Okay, so if you said that conversion was 1 liter is 1,000 milliliters, you are correct. Now, the reason we mapped that out this way is if you remember a few weeks back, I taught you whatever's on the top units, we can cancel with the bottom. So moles cancel and liters cancel, and we're left with that milliliters, which is what the problem asked for. So we know we solved the problem correctly. 99% of the time, if you can get the correct units in the end, you're going to have the correct answer. So let's put those numbers into our calculator. So 0.01 divided by 0.25 times 1,000. We should get 40 milliliters of H2SO4. Look how nice and neat that answer was. After all of that hard work, we got a nice answer. So hopefully that's making sense. If you have any questions on this problem, let me know in the chat. I would be more than happy to answer them for you. I'm so proud of everyone who got through this problem. It was a really difficult one, but we did it, and hopefully it makes sense. Again, if you're not understanding, let me know. If you have some questions of things you went over in class, whether that be homework or something you did on the board, let me know. I'd be more than happy to help you. I want this live stream to be personalized to you and your learning needs. And now let's move on to our next question. So we have methane reacts with chlorine to produce carbon tetrachloride and hydrochloric acid. So we have that balanced chemical equation again, all balanced tonight. If you start with 10 liters of methane at STP, how many grams of HCl are produced? This is another little tough one. So we've got this. We're going to do great. I'm going to give y'all 1 minute. Anything you know about this problem, any ideas you might have about how we solve it, let me know in the chat. This live stream is from the USA. So any questions you have about chemistry, math, stoichiometry, let me know, and I'd be happy to answer them. All right, so you got about 45 more seconds. Anything you know about this problem, let me know in the comments in the chat section from wherever you're streaming. I did give y'all a hint on this one, so I was kind of nice with it. About 30 more seconds. These questions are more college focused or later high school focused. But I encourage you, if you have a strong chemistry knowledge, or even if you don't have a strong chemistry knowledge, follow along and you'll definitely learn something tonight. All right, we've got we're at 30 seconds, so now it is time to solve. So the way we're going to solve this is we're going to start with our 10 liters of methane. This one's easy because it's the only, whoa, that's a weird shape it did. Because it's the only number it gives us. So we're going to do 10 liters, and we want to go to moles of methane. Remember, we always want to go to moles if we're converting between things. HCl is not the same as methane, so we have to go to moles. So that cues us that our liters of CH4 is going to go to moles of CH4. Now, here's where the hint comes in. Because the methane, which is a gas, is at standard temperature and pressure, that's what STP stands for, we can say there's 22.4 liters per mole. STP, which is standard temperature and pressure, is 1 atm, and then I think it's 1 mole. It has these values, and it's at 273.15 K. It has these values. It's not very likely that a gas would be at STP, but it is very likely that your teacher would ask you a question about a gas at STP. I think I'm a chemical engineer. Every chemistry class I've had, majority of questions are about gases at STP. So it's very important, even though it's not very likely. So we have that conversion from liters of CH4 to moles of CH4. Now let's go from moles of CH4 to moles of HCl, and then moles of HCl to grams of HCl. We're just following the path the problem leads us. If you have any questions about how I figure out what steps to take, I'd be more than happy to explain that and help you. I will say it just comes with practice. That's why these live streams are so great. Getting practice doing a variety of problems really helps your chemistry intuition. So we've got this, and y'all have got 30 seconds. Give me those conversion numbers. We'll do the same thing as last time. The person who gets the most correct answers wins, gets a shout out or something. Virtual high five. So you got about 25 more seconds. Any of these numbers you can figure out for the conversions, let me know in the chat. Ten more seconds, guys. All right. 5, 4, 3, 2, 1. So like we've done in almost every problem tonight, the moles of HCl to moles of CH4 is from that balanced chemical equation right here. So 1 mole of CH4 from that coefficient, 4 moles of HCl from that coefficient. And then that moles to grams of HCl, we'll do a quick little molar mass conversion. So we have 1 mole of H, 1 mole of Cl times 1.01 grams per mole times 35.45 grams per mole. Those moles will cancel out. We'll be left with grams. We get 1.01. We get 35.45. We're left with 36.46 grams per mole. All right, so we have now the problem all set up. So let's put it into our calculators to figure out the answer. You've got 30 seconds starting now. All right, about 15 more seconds. 3, 2, 1. If you put that in your calculator, you should get 65.11 grams of HCl. We answered the problem because we got the grams of HCl, which is what the problem asked for. Our answer was 65.11. Just to go back through those steps, we started out with our liters. We converted using that standard temperature and pressure. And then we went to our moles, which is what we have to do to go between compounds. Then we went from our moles of our methane to our moles of our hydrochloric acid. And then we did that conversion with the molar mass to get to grams. Hopefully that's making sense. If it's not making sense, let me know in the chat, and I'd be more than happy to help you. We are about 3/4 of the way through the live stream. So we're to our final minutes to ask questions. So any questions you have, stoichiometry, chemistry, math related, let me know. I'd be more than happy to help you. I want this to be a great learning experience. And if you're wanting to go to any more live streams this week to help prepare for finals or for those tests, there's a QR code in the top left with all of that information for all the live streams Chegg offers. So again, these are your final 14, 15 minutes to ask questions. And while we're waiting for some questions, we are going to solve this problem about empirical and molecular formula. Another new one that we've never done on a live stream, but I'm sure that your teachers have gone over it. So I want to give y'all a minute to tell me what all you know about empirical and molecular formulas. So do you know what an empirical formula is? Do you know what a molecular formula is? Do you know how to even solve these problems? Let me know so that I can kind of get a gauge from where we are. And we will pick back up in 1 minute to start solving. All right, about 30 more seconds. $15 more seconds. Three, two, one. All right, so let's kind of do a little conceptual what empirical versus molecular formula is. So empirical formula is the simplest whole number ratio of a compound. Now we have these molecular arrangements in chemistry, which is where multiple compounds band together and create like a mega compound. You can think of it like that, where it's not the simplest whole number ratio, but it is that compound. So our molecular is those mega compounds. So let's say CH4 is your compound. C2H8, C3H12, those are all part of the same molecular formula. So the molecular compounds are very big. Now, what we want to do is figure out the empirical and molecular formulas. What we're going to do first is we're going to arrange it by atom. So we have C, H, and O. First step, we want to convert our percentages to decimals so that we can find the empirical and molecular formulas. So we would do 40% carbon divided by 100 to get 0.4 as our decimal. Same here, 6.7% divided by 100. We get 0.067 as our decimal. 53.3% divided by 100 to get 0.533 as our decimal. So that is our start. Now what we're going to do is multiply by that overall molar mass, which is this 180 grams, to figure out how much grams these elements make up of the compound overall. So 180 times 180 for all of them. I'm going to give y'all 30 seconds to put these calculations into your calculator. I'm going to start writing the answers, but don't look until you've solved them. Try to beat me to solving these questions. You've got about 10 more seconds. All right, you can look up here now and you'll find the answers. So basically, how much grams of these individual elements make up the compound. Now we have one more step. I'm going to give y'all 30 seconds. What's that last step to figure out how much of each element there is and to figure out that molecular formula? Got 30 seconds. Let me know in the chat how you would solve this and find the molecular and empirical formula. And if you have any questions that you need help with or answers to, let me know in the chat and I'd be more than happy to answer them for you. All right. So the way we're going to get our answer almost completely is by dividing by the molar mass for each. So I'm going to the periodic table, I'm finding that decimal point number, and I'm going to divide. So if I go to the periodic table, I have 12.01 grams of C per mole. For H, I would have, that should be H, and that should be O. Kind of got a little bit mistaken there. So then divided by 1.01 grams of H, divided by 16 grams for O. All of those are those decimal numbers from the periodic table. That's where I got the numbers there. And now let's just divide, and we're going to round to the closest whole number. So we have 6 here. We have 12 here. And let's put this in the calculator. I think it's 6 again, but I just want to be sure. Yep, 6. So now we have these numbers, 6, 12, 6. What do they mean, though? That's our molecular formula. So we'd write C, H, and O out. And then these numbers tell us how many is in that compound. So our molecular formula is C6H12O6. Our empirical formula is, does anyone have any ideas on how we would figure out the empirical formula? Got 30 seconds. Try to beat me and the other people to finding the empirical formula. "15 seconds. What is the empirical formula for this problem?" Three, two, one. So the way we would do this is we divide, or we basically like reduce it to the lowest it can go. So think fractions. Think, what are all these numbers divisible by? When I'm like, okay, what is 6, 12, and 6 all divisible by? The answer is 6. So I divide all these numbers by 6, and I get CH2O as my empirical formula. Hopefully that made sense. It is our first time doing one of these problems, so if it's a little confusing, let me know in the chat. I would love to help. We're to our last 6 minutes of this live stream, so again, your last chance to ask any questions you have. If we don't have any questions, I'm going to give you a problem to kind of try to stump you, I think. So I'm going to give y'all about 10 more seconds. Ask any questions. If not, we are going to do a difficult electron configuration problem. So I love electron configurations, and I know your teachers love them as well. So let's do this. I want you to find the long and short electron configuration of S SR, SR2 plus. SR is strontium, if you aren't familiar, so long and short electron configuration. I'm going to start writing in 40 seconds, so you've got 40 seconds to try to beat me to solving, and then I'm going to start writing. So try to figure out the long and short for strontium 2 plus. It has that charge. That charge is going to be super, super important. If you don't use the charge correctly, the electron configuration will be wrong. Five more seconds. I'm going to start writing. 3, 2, 1. All right. I'm going to pull up my periodic table. I'm going to start in that top row. I have hydrogen and helium. That's 1s2. I go down a row to lithium and beryllium, 2s2. All the way to the right to boron. I have 6 elements there, still not to my strontium. So I have 2p6. Go down all the way to the left. I'm at sodium. So I'm at 3s2. To the right of the periodic table, I'm at aluminum, 3p6. Go down a row. To the left, I'm at potassium, 4s2. Then I hit Sc, which is scandium, and that goes down to 3d10. We talked about those larger energy levels go back a subshell. So we're at 3d10, then we go to the right and we're at 4p6. Then we go down and we're at 5s2. But here's the trick. We have that 2 plus on the strontium. What does the 2 plus mean? The 2 plus means there's a charge of 2 positives, which means we're losing 2 electrons. And those 2 electrons that we've lost just happen to be the electrons that the rubidium and the strontium represent. So this would actually be our complete long configuration. Those 5s2, that 5s2 subshell does not exist because of that 2 plus charge. We're saying those 2 electrons are gone and it is at an elevated energy state. Hopefully that makes sense. I know that was a little bit confusing, but I know my teacher loved to trick us with some ion electron configurations, and this is a great one to start. It's a little difficult, but it's also an easier ion one to do. So now we're going to do the short configuration. To go to the short configuration, we go up a row all the way to the right to that last noble gas. That last noble gas is krypton. So if you watch Superman, you know what krypton is. It's Superman's weakness. And then all we have to do after that is write the electron configuration that's left. But again, well, actually, first, before I say that, what is the short configuration? If I have krypton, what else do I need to add? Let's do 10 seconds. What else do I need to add to this short configuration? I'm trying to trick you guys. That's your hint. 3, 2, 1. All right, the trick is I add nothing because think about that long electron configuration above. We want the long electron configuration and the short electron configuration to match. Krypton, this is the electron configuration of krypton right here. We don't have those 2 last electrons, so all our short electron configuration is krypton in brackets. Hopefully that makes sense. I know that was a little quick for an electron configuration, but it was a kind of simple one to get you introduced to the idea of ions. It was so great to have you on this live stream. Join me again next week, same time. I had a great time with you guys. Come prepared with questions so that we can answer them and we can all learn something. Thank you so much to Chegg for putting this live stream together. Check out that QR code in the top left for our office hours all week long. We have calculus, organic chemistry, algebra. So any subject that you are needing help on as you prepare for finals, prepare for those last tests, join the live streams. Come back again next week, and good luck as you guys end the semester.